Okay, here is Magnetism Lesson 2. All right, so at the end of the last lesson, we just finished up with our anticipation guide, reading 12.2, some vocab as well. All right, so what's important here is that we have that a moving charge creates a magnetic field. So we have field theory. Field theory here is basically how we summarize the three fields we've learned about: gravitational, electric, and magnetic. All right, the source of gravitational is mass. It's an attraction only, and its range is infinite. Electric, the source of the electric is electrons or protons. It's really just charge in general. Can attract or repel. All right, just keep track format here. Okay, can attract or repel. All right, and its range is also infinite, but it's much smaller than gravity itself. Right, it's much smaller than gravity itself. Gravity kind of has a real infinite range. Electricity has a much smaller range. So it's the same. It's still infinite, but it's smaller. Right. Then we have magnetic. All right, it is moving electrons. All right, magnetic fields caused by moving electrons. All right, moving electrons. Keep that in mind. If they're moving, they create a magnetic field. If they're not, they're just have an electric field. The direction they can attract or repel, and their range is also infinite, but again, much, much smaller, right? Much, much smaller as we go, okay? Alrighty, so last class we had the two hand rules. The first rule was you used your thumb as the direction electrons flow, and your fingers were the coil or wrapped around the wire and show the magnetic field. The second rule had your fingers were the coil, and your thumb show the direction of the magnet. If there was a coil around a bar magnet, right, where you're making electromagnetic. Okay, this third one here is the third hand rule. All right, it is probably the most complex. All right, it's the most complex. Okay, so we have three parts. If you hold your hand out, you have your left thumb points in the direction of the electron flow. Your fingers indicate the direction of a permanent magnet, right? And so this scenario that we're designing here, that we're setting up, is kind of we have a magnetic field, right? We have a magnetic field of some type. Okay, and we're going to have an electron move into that magnetic field. When we have that, we're going to get what's called magnetic force. All right, and the way we tell the direction of magnetic force is based on this perpendicularity. All right, again, same rule as the other two. Right hand is used for positive moving charges. You will use that, right? We have protons that do move. All right, you have protons that do move, and we do have positrons and a few other things that are positive, alpha particles, all those kinds of things. They are positive, okay? But what's important is the force, field, and velocity are all perpendicular to each other. Perpendicular is very important. If they're not perpendicular, then this will not work, and we're left kind of uncertain. All right, you are going to need to practice this rule. All right, so we're going to practice this first. Okay, electrons travel through a uniform magnetic field, represented by X, directed to the ground as shown below. An observer is looking downward at the moving electrons, the top view, and determine the direction of the magnetic force acting on the electron when it's traveling along the path. So we're going to start with path P. All right, path P here. All right, looks like that. So what we're going to do is if we look up here, all right, the fingers should be the direction of the magnetic field. So you're going to start by putting your fingers pointing into the page. Okay, then your thumb is the direction of the electron flow. So your fingers should be pointing down with your thumb in the direction that the P arrow is going. All right, then you look at where your palm is facing, which way your palm is facing. So your fingers are pointed into the page, right, into the page because of this. Your thumb is pointed in this direction. All right, which should leave your palm facing this way. All right, I know you're going to feel silly doing this the first couple times. Your palm should be facing to the right. So for P, you should have a force is acting to the right for P. Force on P is to the right. Okay, then we're going to have, now we're going to look at Q. All right, so we're going to look at Q. All right, same idea. Your fingers should be pointing, because of the magnetic field, your fingers should be pointing straight down. Right, and then your thumb should be pointing to the left because Q is pointing to the left. All right, so your fingers are going to point into the page, then your thumb is going to point to the left because that's the direction Q is flowing. When you do this, what direction is your palm facing? When you do this properly, and it's kind of hard because your arm has to bend a certain way, is you are going to see that your palm points up. So then the force on Q goes up. right? Because that's the direction of your palm, or north in this case, right? So the force on Q is north, and the force on P is east. All right, so that's kind of the third hand rule and how we use it. All right, let's turn this off. Go to the next page. Okay. Alrighty, so we have electrons. Another example here. Electron travels through a uniform magnetic field directed to the west as shown, and an observer looking downward notices that going on. K, determine the direction of the magnetic force acting on electrons when it's traveling along the path. Alrighty, so same concept here. Let's start with P. Okay, let's start with P. So P, we should have our fingertips pointing to the left, and P is going up. So our fingertips are pointing to the left, and P is going up. So thumb up, fingertips to the left. Which way is your palm facing? Well, we're going to notice that our palm is facing into the page, right? Our palm is facing into the page. So the force on P in this case is into the page, right? Into the page. We're going to use that X for into the page. All right, then we're going to try Q, okay? So Q, if you think about it, we have the magnetic field, so your fingertips should point to the left, and Q should move to the right. What do you notice about that? Okay, if your fingertips are to the left and your thumb is to the right, can you do that? And the answer is no. Fingertips to the left and to the right. So what that tells us, and if we go back a page here, is that this doesn't follow our perpendicular rule, right? This doesn't follow our perpendicular rule because they're not perpendicular to each other, right? They're going to be the same kind of direction, but just opposite. So that's not going to work. So we have to make sure that for this case Q, right, this case Q, there is no force, right? Because they're not perpendicular. So for Q, no force as not, and the symbol for perpendicular looks like that. Okay, this is the symbol for perpendicular. All right, that's the symbol for perpendicular, and we're going to see that in the next lesson. All right. Okay, so next question here. A beam of charged particles are traveling north in the electromagnetic field directed upwards from the ground. So I've got charged particles, and an electromagnetic field that's directed upward from the ground. Remember, we use dots for upwards from the ground. Okay, all right, the beam is deflected to the east, so I know that the force is to the east. The force should be that way. Identify the sign charge on the particle. All right, so we're going to identify the sign charge on the particle. So we have to have, my fingertips have to be pointing up, okay, because of the magnetic field, and my thumb has to be pointing in the direction of the flow. So your thumb should be pointed north. So fingertips up away from the page, thumbs north, right? And then if you see the forces to the right, what hand works, right? Which hand is going to work? Okay, so you're going to kind of use both hands. You're going to have to kind of turn your body a little bit here and there, all right? And you're going to notice that your right hand shows the proper thing. Since my right hand shows the proper thing, the charge is positive. Right? The charge is positive. All right? Since my right hand is what was correct. Okay? That one you're going to have lots of questions about. Try it a couple times. See if you can get it figured out. All right? So that is lesson 2. You can now finish practice problems 1 to 5. It just has to do the direction. All right? And then in here, I want you to summarize the 3 hand rules so they're all on one page. You've rewritten them and you get that second mode of learning. Alrighty, that's it for this lesson. Thanks, you guys.